I think almost all of you have joined our laboratory now, just one person missing. I hope he will join us in a moment. Today we are starting the second part of the laboratory that I am responsible for. That means multi-thread programming. Multi-thread is not the same as multiprocess, as you have already learned from the lecture. You will be using Petret's library. You will be compiling C or C++ program, whichever you want. My assignment descriptions assume C with Petret's library invoked directly, which may be easier to understand because it's more open than things that are hidden in class initializers and things like that. So for that purpose, for understanding, it's probably better to use C+ Petret's library. For actual programming, it's much better to use the C++ with the thread library. Actually, it's the same library. It's just the header that is different. In one case, you include the pthread, and in the other the thread. Okay, but otherwise, it's actually the same library beneath. So whichever you will be using in your lab, it's your preference. I am not trying to convince you to use C and direct Petret's library, because that would be pointless. I just think that for those of you who are just starting programming with threads, it will be easier during the lab to complete the tasks using that. But if you know C++ and with the threads, then by all means you should use that instead. Okay, so today what you will be doing, you will be creating parallel threads, and we want to see that the threads are really working, and you will be solving just one problem: how to create threads and how to complete complete threads. Okay, when you call a program and you want to finish the process, that means the whole program, you use the exit function. Okay, if you invoke a thread and want to finish the thread, you invoke the pthreads exit function. Yes, and actually it behaves very similarly. The only real difference being that if you call the pthreads exit, that means that only a single thread ends. When you create a thread, you use the pthread create function, and one of the arguments you have to give to that function is the name of a function which is to be performed by the thread. So in case of threads, you have a different approach than in the operating systems. You don't use fork, you use pthreads create, and you have also a different concept in this case, because you don't test the return value to distinguish what is done in the parent and what is done in the child. In this case, you defined what is to be done inside the child. So you always one of the arguments of pthreads create is a function. When this function returns, then the pthread exit is performed. So you don't really need to call pthreads exit inside the function. That will be done. It is an error to call exit inside threads unless you want the thread to finish the whole program, but it's never a good idea. Okay, so that's for creating threads. And when you have the threads created, you have at certain point to finish a program. In your case, that means that you should, when you are writing your program, that you should test the keyboard input and then end the program when a key is pressed. So you need to read the keyboard and on that basis decide to end the process. And you should not end the process unless you are certain that all the different threads are already terminated. So that means that when you before you you execute the exit command, you should always make sure that all the threads are already finished. For that, you use the pthreads join function to ensure that is the case. And it is an important thing to do because even though exit does terminate all the threads, which means that if you execute the exit function, all the threads will eventually be stopped. But that will not happen immediately, and actually exit does not enforce any order of ending of the different threads, and also exit also releases memory, closes all unclosed files and so on, and you don't know what is the order it will be doing it in. Actually, in case of threads, that depends a lot on how you have written the threads. So it's a completely unpredictable thing, and if you don't wait for the threads to finish, you might run inside core dumping. That means that failure of your program because it will try to access memory which is already released, or it will be trying to do something on files if you are using files in your program, and the files are already closed. So before you exit a program, I will require you always to first ensure that the various threads are completed. Okay. Any questions or problems that you have before I give you the task? No, I don't hear it. So the task for today is the same for everybody. Each of you will have to write a simple program which will consist of just 3 threads. One thread will be writing the current time every second as a line. So it will write a line stating the time now is something. 1 second later, it will write again, the time now is something, and so on. It will be doing that every 1 second. Okay, every 30 milliseconds, every 300 milliseconds, another thread will be writing something different. It will be writing the text I like and whatever you like. Okay, so each of you will choose what you like and it will be writing that text. how you achieve that a thread does something every 1 second. Okay, in between writing, you put the thread to sleep. You call the micro sleep or sleep function, which sleeps a process. The first one for 1 second, and then micro for 1 microsecond. Microsecond function is written just U second because there is no micro letter in Latin character set. So the function is actually called U, which stands for microsecond, micro sleep. Okay, that means U sleep. And the argument is number of microseconds. You can also use pthread sleep function, which is also in microseconds as an alternative. Doesn't matter which you use today. Okay, so the one thread will be writing one text with the time, the other will be writing text with what you like, and the third thread will be listening in what you press on the keyboard, and if it finds that you pressed some key, it will initialize ending of the whole process. That means ending all the threads. When the threads end, it will execute exit and finish the program completely. Okay, so all of you are doing the same thing today. As soon as you do it, you will be uploading the assignment. But before I analyze the assignment, I will be asking you to present compilation and running of the program on a meeting. That means you will be sharing your screen and showing me that you are compiling the program and running it. Okay, so that's not enough today to just send me an assignment. I would like to see you doing it. Okay, any questions?
We are working in the Linux environment still, right?
Yes, yes, certainly. That was described in the assignment, so I haven't repeated it. Yes, you are working in Linux. You can be using JCC or J++. You are using, for the compilation, you will be using -pthread, the command line option, and actually, I think that's all that you need to know now.
I also have a question.
I'm sorry.
Yes?
So previously we were writing our scripts in .sh file, and
Yeah.
For this laboratory we have to create file with extension C++. Yes.
C++ or CPP, yes.
Okay.
Depending what you are, or C simply if you are using simple C language.
Okay.
Yes.
I have another question.
Yes.
So during presentation, we will need to compile it by hand in console.
Okay. If you write a make file, you can do it not by hand. That's really up to you. I want to see you doing it.
I mean, I'm using IDE with CMake, so this is no good, I guess.
Why not?
Okay.
But you know what you are doing. If you know what you are doing, then yes, fine. CMake is fine with me. Okay, everything clear now? Okay, I will just have a look about your assignments, previous ones. Okay, Mr. Regulski, are you present? Yes, I see.
Yes, I am.
Okay, you are the only one who has some backlog. I may accept the pipelining script delivered late by 1 week, but I will certainly require you to redo the system script. I will not accept that after 21 days. I don't know how you have suddenly submitted the results. So you have to participate in some other groups. For example, after today, after we finish, there is another group or group. They still have one meeting, and of those meetings you will have to redo that that laboratory.
Of course, certainly.
Okay. So I will give you a different task that you will have to do during the class and not at home, because this is to ensure that doing real. Okay, so thanks.